Welcome to the DIY Honda Garage channel. This presentation covers the DTC P1172, which indicates that the air-fuel AF sensor circuit, specifically sensor 1, is operating out of its normal high range. The Honda CR-V models from 2011 to 2016 can encounter this specific Diagnostic Trouble Code, DTC, due to various issues related to the AF sensor. The AF sensor plays a crucial role in determining the correct mixture of air and fuel entering the engine, ensuring optimal combustion and vehicle performance. Located typically in the exhaust system before the catalytic converter, this sensor is pivotal for the engine control unit, ECU, to maintain the correct air-fuel ratio for efficiency and emissions control. Any malfunction can lead to degraded performance and increased emissions, making it essential for technicians to accurately diagnose and resolve this issue. The error description for DTC P1172 revolves around the AF sensor, also known as the oxygen sensor, that is responsible for sending information about the air-fuel mixture to the vehicle's engine control module, ECM. This sensor is positioned upstream of the catalytic converter in the exhaust system. Its primary role is to monitor the level of oxygen in the exhaust gases, which allows the engine management system to adjust the air and fuel mixture accordingly for optimal combustion. If the AF sensor operates out of range high, it indicates that the engine is receiving more fuel than it can effectively burn, leading to rich running conditions. It can cause a decrease in fuel economy and possibly lead to engine performance issues if not addressed. Understanding the role and position of this sensor is crucial for effective troubleshooting and resolution of the DTC. Several underlying factors can lead to the P1172 DTC being triggered. Firstly, a faulty AF sensor itself could be the primary cause, meaning it is unable to accurately measure the air-fuel mixture. Additionally, there could be wiring issues, such as frayed wires or poor connections between the AF sensor and the powertrain control module, PCM, which could impede proper communication. Once electrical integrity is compromised, it can cause incorrect readings and trigger the DTC. Moreover, a malfunctioning PCM might misinterpret the signals from the sensor, leading to inaccurate adjustments to the engine's air-fuel mixture. All these possibilities must be systematically checked to pinpoint the exact cause of the DTC. Drivers may notice multiple symptoms when the P1172 code is triggered. One of the most apparent indications is poor engine performance, including rough idling, stalling, or sluggish acceleration. As the AF sensor provides erroneous data, the engine may run improperly, leading to these operational issues. Additionally, a reduction in fuel efficiency can be observed, as an overly rich air-fuel mixture leads to wasted fuel. This can also make the vehicle more prone to emitting harmful pollutants, potentially failing emissions tests. Furthermore, the illumination of the check engine light on the dashboard alerts the driver to a malfunction in the vehicle's engine management system, serving as a clear sign that immediate attention is needed. The first step in troubleshooting the P1172 code begins by turning the ignition switch to the on position, which powers the vehicle's electronic systems without starting the engine. Following this, the DTC is cleared using the Honda Diagnostic System, HDS. The HDS is a specialized diagnostic tool that assists technicians in reading and clearing trouble codes. After clearing the DTC, the engine should be started and maintained at 3,000 revolutions per minute, RPM, while in parked or neutral. This step ensures that the vehicle reaches the operating temperature necessary for the radiator fan to activate, which is a crucial condition for monitoring the A5 sensor's performance. Finally, it allows technicians to observe real-time data and the OBD status to verify if the error has reoccurred. In this second step, after the engine has been held at the required RPM, the next task is to monitor the OBD status using the HDS. The key indicators to look for are whether the HDS indicates a failed status concerning the DTC. If the diagnostic tool confirms that the AF sensor output is indeed failing, there is a clear recommendation to replace AF sensor 1. This resolution stems from confirming that the sensor is malfunctioning and cannot provide accurate readings necessary for optimal engine management. Once replaced, the troubleshooting process can proceed to a verification stage to ensure that the replacement resolved the issue effectively and return the system to normal operation. If the HDS does not show a failed status after the initial diagnostic procedure, it's crucial to check for poor connections or loose terminals in the wiring related to AF sensor 1 and the powertrain control module, PCM. Over time, vibrations and environmental exposure can lead to deteriorating electrical connections, causing intermittent signal issues that could trigger DTC P1172. Thoroughly inspecting the wiring harness for any signs of damage, repair sense, or replacement of frayed wires is necessary. Additionally, the connections at both the AF sensor and the PCM must be secure. Inspections should be systematic and detailed to identify any visual or operational issues influencing the sensor's performance. The fourth step in the troubleshooting process involves verifying the OBD status after performing the necessary checks on the AF sensor and its connections. If the diagnostic tool indicates an executing condition, it means the system is actively testing the sensor's performance and the result is pending. In this scenario, the technician should continue to drive the vehicle under typical conditions until a definitive result appears. By doing so, they can gather real-time data that might confirm if the issue persists. It's important to note that passing or failing tests can develop over time as the engine operates. Hence, monitoring performance post-diagnostics is essential to restoring the engine management system to its intended functionality. To verify the success of the repair made related to DTC P1172, the technician should first turn the ignition switch to the lock position, which cuts power to the vehicle's systems. Subsequently, all previously disconnected connectors should be securely reconnected to ensure no loose ends could lead to future issues. The next vital step is to reset the powertrain control module, PCM, using the HDS. Resetting the PCM establishes a clean slate for the vehicle's ECM to replace its learned parameters and associated memory from previous diagnostic trouble codes. Following these reconnections and resets ensures that the vehicle's electronic systems are prepared for evaluation and further observation. Preventive maintenance is essential in mitigating issues related to DTC P1172 from arising in the first place. Regularly inspecting the A-factor sensor, especially for signs of wear or contamination, can be beneficial. Ensuring that the wiring remains in good condition, free from fraying or exposure to extreme heat in the exhaust region, is equally important. Moreover, maintaining clean electrical connections prevents corrosion and ensures effective communication between the A-factor sensor and the PCM. Establishing a routine service schedule that includes checking these components helps to prolong the lifespan of the A-factor sensor and maintain optimal vehicle performance. These proactive measures can save time and resources in the long run. In conclusion, understanding the DTC P1172 and its implications is crucial for maintaining Honda CR-V vehicles from 2011 to 2016. The A finger sensor plays a vital role in ensuring the proper functioning of the engine by accurately measuring the air-fuel mixture for combustion efficiency. Following systematic troubleshooting steps helps identify the issue effectively, whether it involves the sensor itself or related wiring and connections. Additionally, implementing preventive maintenance measures, such as regular inspections and keeping connections clean, can significantly reduce the likelihood of future issues. By taking the time to address this DTC thoroughly, technicians can ensure optimal vehicle performance and compliance with emission standards. Please like and subscribe to the channel. See you next time.